Yeah, hello students, this is the second part of Locus. Today I am going to explain some interesting problems. This is first problem. Find the equation of the locus of a point which is equidistant from 1, 3 and the x-axis. Okay, observe students. This is our y-axis, this is x-axis. So, 1, 3 is fixed point which is in first quadrant obviously. Let it be A. Now we want to find out a point P on this plane. Somewhere you don't know where is that. Let it be P x1, y1. What the condition? Find the equation of the locus of point which is equidistant from 1, 3 and x-axis. Distance from P to x-axis and P to A should be same. Okay. This distance should be equal. Obviously, this say PM is nothing but mod y1 only. Distance from point to x-axis. So, I want to write steps nana. Let P x1, y1 be a point on required locus. Okay. What is given condition? PM equal to PA. What is PA nana? Mod y1 equal to PM is distance from P to that point A. So x1 minus 1 whole square plus y1 minus 3 whole square. Squaring on the other side, we will get y square equal to x1 minus 1 whole square plus y1 minus 3 whole square. That is y1 square equal to x1 square plus 1 minus 2x1 plus y1 square plus 9 minus 6y1. Students, important thing is here this y1 square get cancelled. No, I want write conclusion now. Therefore, the required locus is, no, I want drop the suffix x1 and y1s. Directly I want to write the equation is x square minus 2x minus 6y plus 10 equal to 0. This is the required equation of the locus. Means that under this condition only the point P will move, or the path of P will gives a graph which is nothing but x square minus 2x minus 6y plus 10 equal 0 on the coordinate plane. Students, this is our second problem. I can say example 2. Find the equation of locus of a point such that the sum of the squares of the distance from the point 2, 5 and 3, minus 1 is 40. Easy problem. Here two fixed points are given. Say one is A whose coordinates are 2, 5. Another point is say B whose coordinates are 3, minus 1. Now a variable point is moving on this plane. Let it be P whose coordinates are taken as x1, y1. What is the condition? Distance from P to A plus P to B equal 40. Yeah, sum of the squares are PA square plus PB square equal to 40. Such a way that P is moving. So we need to write steps first. Let P x1, y1 be a point on required locus okay. So given condition is PA square plus PB square equal to 40. So PA square means what? Root over something square plus root over something square. Something means the distance should write actually. Yeah, what should write now here? x1 minus 2 whole square plus y1 minus 5 whole square. Actually square root should be, square means automatically that square root will eliminate, plus x1 minus 3 whole square plus y1 plus 1 whole square equal to 40. just we need to simplify this. Yeah, students, this is x1 square plus 4 minus 4x1 plus y1 square plus 25 minus 10y1 plus x1 square plus 9 minus 6x1 plus y1 square plus 1 plus 2y1 equal to 40. Okay, so this x1 square plus x1 square 2x1 square, y1 square plus y1 square 2y1 square minus 4x1 minus 6x1 minus 10x1, somewhere 10y1, this minus 8y1, yeah, 9 plus 25 plus 4 plus 1. Okay, so I will add 10, 35, 34, 34 means minus 5 equal to 0. I want cross check. 9 plus, where is that one? Here. 9 plus 1, 10, 25, 25, 29, 30, 11, sorry, what I wrote wrong. Again I want cross check. Yeah, this 9 plus 1, 10, 10, 35, 39 plus 39 minus 40 equal to 0. So now I want to write Locus equation. Equation is 2x square plus 2y square minus 10x minus 8y minus 1 equal to 0. Yeah, this is our third problem. Find the equation of locus of a point such that its distance from a comma 0 is m times the distance from 0 comma a. Okay, that this is a nana whose coordinates are a comma 0, somewhere b 0 comma a. Obviously this is a point on x axis, this is a point on y axis. So p is moving, say its coordinates are x1 y1. What condition? The equation of the locus of point such that the distance from, yeah, this distance pa equal to m times of pb. That is the condition. Okay, let p x1 comma y1 be a point on required locus. Okay, given condition, PA equal to PB, sorry, m times of PB, or PA means what? Square root of x minus a whole square plus y1 minus 0 square equal to m times of root over x minus 0 whole square plus y1 minus a whole square. Again squaring another side, we will get x1 minus a whole square plus y1 square equal to m square times of x1 square plus y1 minus a whole square. Now we need to simplify this. X1 square plus a square minus 2ax1 plus y1 square equal to m square x1 square plus m square y1 square plus m square a square minus 2m y1a. Okay, now just to directly I want to write locus equation now. The required locus equation. The required locus equation is here. So I want to drop the suffixes. 1 minus m square of x square plus 1 minus m square of y square. Okay, so here one x term, yeah, only one x term. Okay, minus 2ax. Next here one y term, this becomes 2may. Okay, remaining terms a square is there here, m square a square plus what I can write nana, 1 minus m square of a square equal to 0. This is the required locus equation. Next, fourth problem. The point S is 3, 0 and abscissa of m is minus 3. A variable point P is such that the ordinate of P and m are equal. Find the equation of locus of P such that SP equal to Pm. Okay, students, here S is given here. S is given as 3, 0. Somewhere m is there. We don't know what are the coordinate. Somewhere P is there. Whose coordinates are taken as x1, y1. So the point S is 3, 0 and abscissa of m. Abscissa first coordinate is of m minus 3. Okay, I want write it is clearly nana. M here what happened? Minus 3, comma. Yeah, means a variable point P is such that the ordinate of P means y1 and m are equal, means this is also y1. Okay. Find the equation of locus of P such that SP equal to Pm. Okay. So let P x1, y1 be the one of point on required locus. Given condition. SP equal to Pm. SP is distance only, no? Yeah, x1 minus 3 whole square plus y1 minus 0 square equal to Pm. Pm x1 plus 3 whole square plus y1 minus y1 whole square. Squaring another side, x1 minus 3 whole square plus y1 square equal to x1 plus 3 whole square. Now I want to simplify this. X1 square plus 9 minus 6x1 plus y1 square equal to x1 square plus 6x1 plus 9. Some cancellations. x1 square get cancelled. 9 get cancelled. Now I want to write conclusion here. Therefore the required locus is, what is that, y square minus 12x equal to 0. Okay, this is the required locus. It is a parabola. Next question, what is the number previous? This is fourth one. What is next? That is fifth one. I can say example 5. Find the equation of locus of a point which moves such that the ratio of the distances from 2, 0 and 1, 3 is 5:4. Interesting problem. Students, listen. Let A is fixed point whose coordinates are 2, 0. B is another fixed point whose coordinates are 1, 3. P is moving. x1, y1. Let P, x1, y1 be a point on required locus. Okay. So condition, what is the condition? PA by PM equal to 5/4. Okay. What is the meaning of that? 4 times of PA equal to 5 times of PB. What is that? 4 times of PA square, 16 times of PA square equal to 25 times of PB square. Okay, directly I want to write 16 into PA square, x1 minus 2 whole square plus y1 square, direct statement, equal to 25 times of PB square, x1 minus 1 whole square plus y1 minus 3 whole square. Just we need to simplify. 16 x1 square plus 4, 16, 4 that 64 here minus 4 will get 64x1 plus 16y1 square equal to 25x1 square plus 25 minus 50x1 plus 25y1 square plus 25 9s are 45, 9 2s are 18, 225 minus 625 6 are 30, 150 minus 150 y. Okay, now we need to simplify this. Okay students, listen. Yeah, 25x1 square minus 16x1 square. So these two completed. 25y1 square minus 16y1 square is also completed. Next, yeah, this one minus 50x1 plus 64x1. These two completed. Yeah, y1 terms next. Yeah, only here minus 156 or 50, that one I think 50 only. y1. So this complete. Now constant terms I will write all here. Here 25 plus 225 minus 64. Okay. Now I want to simplify this. 9x1 square. Here 4, okay, 9. 25 minus 16, another 9. 9y square, y1 square, sorry. Addition of these two, what happened? Plus 14 x1, okay, yeah, minus 150 y1. This is 25 to 250, 64 subtracted. Here 6, here 4, 8, 186 plus 186 equal to 0. Now I want to write locus equation. Therefore, locus equation is 9x square plus 9y square plus 14x y plus 186 equal to 0. Okay. Okay, our fifth problem, find the equation of locus of point P such that the distance of P from the origin is twice the distance from P to the point A 1, 0. So origin whose coordinates are 0, 0. This A is 1, 2. Variable point is say x1, y1. The P is moving such that the distance from origin to P is twice the distance from P to the point A. Okay, this is K, means this is 2K, such a way that P is moving. Okay, yeah, distance of P from origin is twice the distance from P to A. Okay, let P x1, y1 be a point on required locus. Okay, condition. What is the condition? PO equal to 2 times of PA. And directly I can say PO square equal to 4 times of PA. PO square means distance from P to O, square of that. That is x1 minus 0 whole square plus y1 minus 0 whole square 4 times of, yeah, here should write square, okay, x minus 1 whole square plus y1 minus 2 whole square. Just to simplify this, then x1 square plus y1 square 4 times of x1 square plus 1 minus 2x1 plus y1 square plus 4 minus 4y1. Okay students, now I want to simplify. Okay, x1 square plus y1 square equal to 4x1 square plus 4 minus 8x1 plus 4y1 square plus 16 minus 16y1. Now we need to simplify this. So observe students, transfer these two terms to right hand side. 3x1 square plus 3y1 square, yeah, minus 8x1 minus 16y1. What is here? 16 plus 4 plus 20 equal to 0. Now I want to write required locus. Therefore required locus is what I can say, 3x square plus 3y square minus 8x minus 16y plus 20 equal to 0. Sometimes I will make a point which is equidistant from two coordinate axes. Interesting problem. This is our y-axis, x-axis. P is a variable point such that distance from x-axis to y-axis equidistant, when these two distances are equal. So this is mod x1, so this is what is then mod y1. So this is a m and n, given mod x1 equal to mod y1. So first of all you need to write steps. Let P x1 comma y1 be a point on required locus. Okay, given condition Pm equal to Pn or mod y1 equal to mod x1 or squaring y1 square equal to x1 square. Therefore the required locus locus equation is x square minus y square equal to 0, or sometimes I can say that x plus y into x minus y equal to 0. Yeah, another difficult problem, 7th problem. Find the equation of locus of P such that the P is moving under this condition. So let P x1 comma y1 be a point on required locus. Okay, so I want that condition first. PA square plus PB square equal to 2 small c square, that is different c. No. Yeah, A stand for here small a comma 0, B stand for A is 2 comma 3, B is minus 1 comma 5 are two fixed points. P is a variable point. What condition it is moving? For example, P is one of the points, say x1, y1. Find the equation of locus of P if the line segment joining this line segment is making 90 degree at that particular point. What is the locus of point? Obviously, from plane geometry concept, we can say that locus is nothing but a circle, because angle in semicircle is 90 degree. This is 90, this is 90, this is 90, this is 90. Means what condition the P is moving means I can say that it will form a circle. But here you want to find locus equation. Okay, so let P x1 comma y1 be a point on required locus. What the condition means I will write. What is the condition? PA is perpendicular to PB. several ways you can solve the problem. Nana. One of the ways P is AB square equal to PA square plus PB square from right triangle property, or by slope concept I can say that slope of PA into slope of PB equal to -1. That is better. Slope of PA into slope of PB is equal to -1. Okay. So y1 minus 3 by x1 minus 2 into y1 minus 5 by x1 plus 1 equal to -1. Now we need to simplify this. So I will complete here only. Yeah, y1 minus 3 into y1 minus 5 equal to -1 times of x1 minus 2 into x1 plus 1, or y1 square minus 8y1 plus 15 plus x1 square minus x1 minus 2 equal to 0. So x1 square plus y1 square minus 9, not 9, wait, actually x1 minus 8y1, yeah, plus 13 equal to 0. Now I want to write it in as a conclusion. Therefore the locus equation is x square plus y square minus x minus 8y plus 13 equal to 0. Okay, our ninth problem, find the equation of the locus of P if A 4, 0, B minus 4, 0 and PA mod PA minus PB equal to 4. Okay students, let P x1 comma y1 be a point on required locus. Given condition is what? PA minus PB equal to 4, or PA minus PB equal to plus or minus 4, or PA equal to plus or minus 4 plus PB. Okay, squaring another side, PA square equal to 16 plus PB square minus or plus 8PB. Okay, now PA square means what? x1 minus 4 whole square plus y1 square equal to 16 plus PB square means x1 plus 4 whole square plus y1 square minus r plus 8PB. You write as it is, don't disturb that. Now here what happened? This y1 square get cancelled. Yeah, now x1 square plus 16 minus 8x1 equal to 16 plus x1 square plus 16 plus 8x1 minus r plus PB, 8PB. 1 minute, 8PB. So here are some cancellations. x1 square 16, x1 square 16. Transfer these two terms to left hand side. What will get? Minus 16x1 minus 16 equal to minus plus 8PB. Okay, or in other words, what I can say, if minus 16 taken common, x1 plus 1 equal to minus 8PB. 1s are 8 2s are, what I can say, 2 times of x1 plus 1 equal to minus r plus, actually minus r plus what, no problem, no, that is not a big issue. Minus r plus, no, becomes plus r minus PB. Okay, again squaring, yeah, 4 times of x1 plus 1 square equal to pb square. So 4x1 square plus 4 plus 8x1 is equal to pb square means already we did somewhere x1 plus 4 whole square plus y1 square, that one I want, right? x1 square plus 16 plus 8x1 plus y1 square. Okay, now transfer all these terms to left hand side. 3x1 square. Okay. This get cancelled. Minus y1 square equal to 12. Therefore, the locus equation is 3x square minus y square equal to 12. Okay, our 10th problem, A 5, 3 and B 3, minus 2 are the two fixed points. Okay, first of all, two fixed points are given here. A 5, 3 and B 3, minus 2. Find the equation of locus of P so that the area of the triangle PAB is 9 square units. Okay. So P is a variable point. This is one of points say P. So that its area equal to 9 square units. Such a way that P is moving. We want to find locus equation of P. So this is interesting problem, students, because listen, this is a line segment AB. Okay. We want to find out the locus of point P, which is makes an area of 9 with this line segment AB. For example, one of such point is this, so that area of triangle PBB equal to 9 square units. Do one thing, through P draw a line parallel to AB. Take one more point Q on that line other than P and join AQ and QB. What is the area of triangle AQB? That is also 9 only. Why? Triangles with the same base between same parallel line, their areas are equal. You take any point on that line, all will make area of 9 with the line segment AB only. So what happened? What I can say? The locus of P is nothing but a straight line. Locus, I am not saying locus equation. Locus is nothing but a straight line. One thing. Do one thing, take one more point exist which is below the AB, so that area of this triangle also 9 square units. The meaning is that through this point also can draw a line parallel to AB. Every point on this line also satisfies the same condition. So what is the meaning of that? The locus is nothing but two parallel straight lines. Every point on this straight line will satisfy. Every point on this straight line will satisfy. In plane geometry sense, what I can say? The locus is nothing but a pair of straight lines, okay, which are parallel to each other and parallel to AB, and which are either side of AB. But in this problem, what should do now? We want to find locus equation. We want to find equation satisfied these points. We want to find equation at these points. After that, we need to multiply those two. Okay. I want to write steps for that. Let P x1, y1 be a point on required locus. Given condition, area of triangle PAB equal to 9 square units. So delta equal to half into, we have the formula x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2 square units. So let this is say x1 y1, say this x2 y2, say this is x3 y3. Students, substitutions 9 equal to 1 by 2 into x1 means 5, y2 means minus 2, y3 means y1 plus x2 means 3, y3 where is that, y1 minus y1 means 3, cross check, x2 where is that, x2 3 only, okay, plus x3 means x1 into y1 means 3 minus y2 means plus 2, okay. So this is nothing but 18 equal to modulus of 3 plus 2 5x1, here minus 10 minus 5y1 plus 3y1 minus 9, or 18 equal to 5x1, yeah, minus 2y1 minus 19. Okay students, now I want to open modulus. Actually you need to squaring another side, that is one of the method, or directly you can write plus or minus, okay, that is 5x minus 2y1 minus 19 equal to 18, or 5x1 x1 should write minus 2y1 minus 19 equal to minus 18. What it gives? 5x1 minus 2y1 minus 37 equal to 0, or 5x1 minus 2y1 minus 1 equal to 0. So therefore the required locus equation actually all the point on this line will satisfy, all the points on this line will satisfy, but combined equation you want, that's why you need to multiply them. 5x minus 2y minus 37 into 5x minus 2y minus 1 equal to 0. This is the locus equation.